Okay, so now I'm gonna go through some examples on 11.7. I'm not gonna solve them. I'm just gonna tell you what I think about them and kind of lead you in the right direction. Not that my direction is always right. So let's look at this first one. I got 1 to infinity, and I got 1 over n plus 3 to the nth power. Do I think that guy converges? First thing I'm gonna check, is it going to 0? Is inside's going to 0? Definitely. I got 1 over, numbers getting bigger and bigger. It definitely goes to 0. So I got to check a little farther. On this one, I probably would use the comparison test because it looks like, it doesn't look like, it is. That guy's less than 1 over 3 to the n, and that's equal to 1/3 to the n. That would give me a convergent geometric series, and this guy's less than that, and that would give me this guy's SNs to be increasing, his partial sums be increasing, but bounded by this number. So I think this guy would converge, and I'd used just a straight up comparison test on this one and compare it to this a series made out of this sequence. Okay. So the second one, so I think this guy would, and I would go through and probably use a comparison test on that one. On this guy, look at this one. Okay, it's an alternating series, so I'm happy. All I got to do is show that this guy gets small, and I'm done. Oops, what's the first thing you're always supposed to check? Do the insides go to 0? What's n over n plus 2 going to go to? As n gets big, do you care about the 2? No, that's going to look like n over n. That's going to go to 1. This guy's actually going to go to a -1 and a +1. So it's going to bounce back and forth, getting closer and closer to 1 and closer to -1. So this guy does not go to 0. Therefore, this guy diverges. Okay. Next, this one looks really complicated. Now, you first look at it, you might think the root test, because I got 2 to the n minus 1. I could deal with that, and maybe take a half off of that, and I'd have 2 to the n. Or it could even be kind of like the geometric series, because you get 2 to the n over 5 to the n. But I'm not going to use the root test because the root test is going to get screwed up with this guy right here. So maybe I use the ratio test. Ratio test would probably work on this guy. Another thing, if you look at it a little closer, there's a -1 to the n. This guy's an alternating series. All I got to do is show this guy decreases, which I believe it is. Now it's got this n squared on top, which is going to be making the top grow, but I got it 5 to the n on bottom. I got an exponential on the bottom, a polynomial on top. This is going to beat it, and after a while, this guy's going to decrease. So I think I would probably use the alternating series test and just show that this guy decreases, and I know it's alternating. And then, while I want to do that, that's better than using the ratio test, because now if it's alternating, I can get a bound on this guy's error if I use so many terms. So I think I'd use the alternating series test on this guy, and I do believe that guy converges. Now this one, look at this guy. Do you think this converges? The insides go to 0? Yes, the insides do go to 0, but what does that look like? To me, that looks like 1 over n. Now this guy is less than 1 over n, and this guy blows up, so I can't use a straight up comparison test, but I can use the limit comparison test. So on this guy, I use the limit comparison test, and I'm positive that this guy will blow up. Okay, so there's some more up here and kind of give you some ideas on what I'd be thinking about. Okay, so I picked out some other examples. Let's look at the summation n equals 1 to infinity of -1 to the n, and I got 1 over square root of n minus 1. Okay, look at this series. Is it alternating? Yes, it is. It's going plus minus plus minus. So I can alternate series. All I got to do is show that that is decreasing. Is it decreasing? Well, as n gets bigger, I got 1 over n as minus the 1, but 1 over n, they're getting bigger and bigger and bigger. Even though I take square root, still getting bigger and bigger. So this thing is decreasing, and it's alternating. So I do a little bit more work on this guy, but I can almost guarantee you this guy would converge. Okay, using the alternating series test. Then I got summation n equals 1 to infinity of 3n, And then I got n squared over n factorial. Now, you might look at this guy and you might not be positive that the insides even go to 0. They do, because this is a screaming fast function. It's faster than either of these two. But you might have to do a little work to show this guy goes to 0. But if you're a little confused, you can use the ratio test. It's got a factorial in it, so I'm automatically going to use the ratio test on this. So I use a ratio test on this guy, and I do believe that one's going to converge. Pretty positive, but I'd have to prove it using a ratio test. Let's look at, take the summation n equals 1 to infinity, and we got sine of 2n over 1 plus 2 to the n. Okay, looking at that guy, do you believe it converges? I think it does, because how big is sine going to get? No bigger than 1. And I got 1 plus, and there is a ratio. So what am I going to do? I'm going to compare, I'm going to look at this guy here, sine of 2n. Now, I can't use a straight up comparison test because these guys aren't positive, but if I drop absolute values on them, now this guy's positive. And now I can compare that guy with 1 over 2 to the n. Now, who's bigger, this guy or that guy? Here I got more numbers on the bottom. I added 1 to the bottom. That made the bottom bigger, which made the whole thing smaller. And then the top, this guy is always going to be less than 1, so I know that. Why do you know about this? That's a convergent geometric series. So that guy converges, means this guy can converge, so that guy's going to converge absolutely. Okay, last one. Let's look at, I'm going to raise it so I get up a little higher. Let's look at summation n equals 1 to infinity of a minus 1 to the n cosine of 1 over n squared. What do you think is going to happen to this guy? Okay, it's alternating. Don't let the alternating suck you in. What's happening to this? As n goes to infinity, that's going to 0. What's cosine at 0? Cosine at 0 is 1. So this thing's actually bouncing back and forth between 1 and getting closer. It's bouncing back and forth and getting closer and closer to 1 and negative 1. Did the insides go to 0? No, they did not. So this guy diverges. Okay. So that's kind of how I'd look at these guys. Again, it didn't work completely out, but that's a thought process I'd go just set up before and start actually writing it out and proving them rigorously. All right. Bye.